So thank you for coming and welcome to the talk. I'm Deepu K. Sasidharan. Well, officially Deepu Sasidharan because I had to change my name in my Dutch passport. Come and ask me why I had to change it. Uh, I'm the co-lead of JHipster. How many of you have used or heard about JHipster? Hey, nice. Do you like it? Hands up if you like it. Come on. Really? You're so mean. Anyway, JHipster is cool. I work as a developer advocate for Okta, specifically focusing on the Auth0 product, which is the customer identity solution for end user facing stuff. I have built a lot of open source software, kind of an open source aficionado. That's what I call myself. I'm a polyglot developer, mainly working with Java, Rust, Go. I stopped doing JavaScript. It's too much to keep up. It's just too much. So, yeah, so I'm going to talk about passwordless, right? So, first things first, why do we even need passwordless? I mean, passwords have been around for more than 1,000 years, right? And it seems pretty all right. And of course, we are all very happy sharing our Netflix passwords. It's so convenient, right? So, why do we have to stop doing that? Well, the main reason is the password problem. That's what I would like to call it. I don't think we are evolved as a species to use passwords properly. Even though it has been 1,000 years, I don't think we are using it properly. We're not built to use passwords properly. According to a data breach investigation report from Verizon from 2021, credential compromises account for over 84% of all data breaches, and out of that, phishing is 36%. So we can see why it is a problem, right? And according to me, the password problem is actually a human problem, right? Because passwords rely on us to do a bunch of stuff, like we need to remember them, we need to store them securely, we're not supposed to share them. Like, how are we supposed to do Netflix then, right? So, and history has a quadrillion times shown us that we are not good at doing any of this. We are not built for any of this. So we end up reusing our passwords, we end up sharing our passwords, we end up having 1, 2, 3, 4, 5 as passwords sometimes, We end up doing all those stupid things. So, and among all these problems, right, the biggest problem is social engineering, right? We can be social engineered, either to divulge our passwords directly or at least to gain some information to go to our passwords. Maybe not all of us, but many of us can be social engineered. And most of the data breaches, when you look at the root cause, are social engineering related stuff, phishing, social engineering, these kind of things. So we also reuse and share passwords, making them even more vulnerable. So it is technically not a password problem or like technology problem, it is an us problem. And another problem with password-based systems are passwords are knowledge-based, right? So you need to remember them, and they are very hassle. If they are simple enough or easy to remember, then they are also easy to guess. If they are complex, then yeah, you need to end up you need to use a password manager to save those, or you end up reusing passwords because complex passwords are hard to remember. You cannot. How many of you have not ever reused passwords? Wow. Salute, sir. It's just impossible, right? I cannot remember more than 2 complex passwords. That's my limit for complex passwords. So password managers, of course, are great, and we should all use a password manager, but it's still an overhead, right? I mean, it would be nice if you don't have to use another tool to remember our passwords, and we can just log into websites, right? How many of you use password managers? Yay, everyone. Should I ask the other? How many of you don't use password managers? Shame on you, man. I'm sorry. Sorry for being mean. Of course. So Passwords are not just a hassle for end users, right? It is also a hassle for people who are building websites, maintaining servers, because when you have passwords, you also have to do a lot more on the server side. You have to secure them, you have to encrypt them, you have to secure them, you have to make sure your entire thing is very secure, because when someone breaches passwords, all your user accounts are compromised, right? So you have to do way more. You have to implement MFA flows, like multi-factor authentication flows and stuff to secure them further. You have to build password recovery flows, reset flows, and all sort of things, right? And all this takes up time, and all this also costs money. Did you know that each password reset on average costs around $100 on average for a company, each password reset? So these are costs that actually can be avoided if you're not using passwords, right? So like the obvious solution is go passwordless, right? So let's see what exactly is passwordless. Of course, the term itself is quite obvious, but still, if you can verify a user's identity with something other than a password as the first factor, then that is a passwordless flow. So using a password and then doing an MFA is not passwordless. So for a passwordless flow, you should not be using any sort of, you don't have to remember anything and type it in. That's the basic thing. And of course, we have been doing this for a while. We all use biometrics on our phones, on our laptops and stuff. So that is kind of semi-passwordless, I would say. And there have been some forms of passwordless around. You might have encountered this in here and there on some random services. I don't think everyone does these things, but there will be some service which sends you a magic email link instead of passwords. Like I think Open Collective does that. They don't have passwords. You always get a link to your email, and you use that to sign in. So that's kind of passwordless. There are also systems where you can use an OTP-based passwordless flow, like Auth0, for example, supports that. Whenever you try to sign in, you get an OTP in your SMS or email, which you use to sign in, so you don't remember passwords. Also, similarly, you can have push notification. Google does that. You get push notifications to sign into services when you configure that. So these are kind of passwordless flows that we have. But most of these methods are not secure enough to completely replace passwords and or completely replace password plus MFA combinations, especially because passwords plus MFA are quite secure, and these cannot replace that. These are not as secure as those, and that is where passkeys come into the picture. So a secure passwordless future, according to me at least, is passkeys, right? You probably encountered passkeys here and there because Google and GitHub recently started rolling it out to all users. So how many of you actually set up a passkey with one of these services, or any services for that matter? Okay, I see not a lot of people, but great. Yeah, there is an option for you to do this in GitHub and Google. It supports for all users these days. So passkey is a unique cryptographic key pair, right? So it's a public-private key pair, which you can use to access online services without using passwords. So obvious from the name. I mean, the term passkey itself doesn't say much. It's a marketing term that later become like an industry term. We'll get there. It is based on asymmetric cryptography, public key cryptography. So how many of you think multi-factor authentication is the same as passkeys? Great, awesome. Because I have been in conversations where people mistake these two. We'll get to that as well. So according to FIDO, the organization that kind of standardizes these things, passkeys are a password replacement that provides faster, easier, and more secure sign-in to websites and apps across a user's device. Unlike passwords, passkeys are resistant to phishing and are always strong, and are designed so that there are no shared secrets. This is like the official definition of passkeys. But we'll dive in and we'll look into this. But before we talk about passkeys and before we dive deeper, we need to understand a few terminologies and a few other technologies. So WebAuthn, short for Web Authentication, is the W3C specification that defines how a web page can use a JavaScript API to talk to authenticators. Roaming authenticators, which are YubiKeys, your Titan keys, and these things, or platform authenticators, which are Touch IDs, Face IDs, Windows Hello, or your Android biometrics, and all these things. Another standard terminology to know is FIDO. FIDO stands for Fast Identity Online. It's a global authentication standard based on public key cryptography. It is developed by the FIDO Alliance, which is an association of industry leaders who care about securing authentication on those things, going passwordless and all these things. So FIDO aims to solve all our password problems. That's their official goal. We'll talk about those in a minute. So FIDO 2 is the specific set of standards used for passkeys. We'll also see more about that. So in short, so passkeys are passwordless FIDO credentials with WebAuthn, right? The term passkeys itself is just a marketing term. It was popularized by Google and Apple. So originally it was FIDO multi-device credentials, but it doesn't have a nice ring to it and very hard for people to remember. So I understand why they went with passkeys. It is implemented using the WebAuthn specification, as I mentioned. But recently, that definition has evolved to mean any passwordless FIDO credentials. It is not just multi-device credentials, but any passwordless FIDO credentials which are discoverable by the browser. So that's the official terminology now, like the technical terminology. But let's just go with passkeys because FIDO also kind of accepted it as the official term for that technical term. So we'll just go with passkeys. I think that's going to be the name or the term that is going to catch on and that is going to be widely used. So passkeys have two variants. So there is synced passkeys or synchronized passkeys, and there is hardware-bound or device-bound passkeys. These are the two variants. Synced passkeys have a better user experience. For example, in the Apple ecosystem, your private key is synced on your iCloud keychain, and they are replicated across your Apple devices. So you can register in your MacBook laptop, and then you can use your iPhone to sign into the same website. So you don't have to manually sync anything. So you can use the ecosystem to do the synchronization of your private key. You can also do the same with the Google ecosystem. If you're using Chrome browser, it can also synchronize your passkeys across devices where you have Chrome browser. And whenever you install Chrome browser on a new device, it gets automatically synced to that as well. So, or you could use your password manager, for example. I think most password managers also started supporting storing passkeys, like Bitwarden. I think 1Password also started doing it. So you can create passkeys in your password manager as well, if you like. It will do the job of synchronizing that to all your devices. We'll go into all those, how the synchronization happens on all later on. But these are kind of the differences between these two. So when it comes to the hardware-bound passkeys or the device-bound passkeys, the private key stays in the authenticator itself. For example, if you're using YubiKey, your private key stays on that particular YubiKey. It doesn't go anywhere else. So it is much more secure because you're not letting it wander into the cloud. You have complete control over that. But it is also not as convenient as sync passkeys because you have to use the YubiKey everywhere. But I use that. I have a Linux laptop, so there's no support for platform authenticators, though I have a biometric, but yeah, it's Linux. It's not going to work, right? So I use the YubiKey instead. I think the synchronized aspect is nice, but not a big deal because I still can use my YubiKey in all devices wherever I want, right? I just have to remember to carry it with me. So that's the only thing. So it is much more secure. This is the most secure option. So hardware-bound passkeys are the most secure option, followed by sync passkeys, but sync passkeys have a better user experience. So as I mentioned, passkeys use web authentication underneath. So web authentication works by using, again, public key cryptography. It uses FIDO2 and credential management level 1 specs to do this. The process is quite straightforward and simple, actually. We have 3 entities. We have an authenticator, which could be, as I mentioned, roaming authenticators like YubiKeys, Titan keys, or whatever hardware tokens you are using. Or it could be platform authenticators like Touch ID, Face ID, Windows Hello, whatever the TPMs on your laptops, if it is supported, all those things. right? Then we have the relaying party, which is nothing but the backend server where the user information needs to be stored, where the signatures needs to be verified. So it could be your own implementation, your own, for example, your own Java server doing this, or it could be an IDP like Auth0, Okta, or Google, or Facebook, any OIDC provider who supports passkeys. It could be your relaying party. And then the last entity is the client, which encompasses of your browser's user agent and the user itself, right? So these three entities work together in web authentication. So the user authenticates using the platform or the authenticator. That is the job of the user. They do the authentication physically by either touching your key or by touching your fingerprint or doing your face unlock or whatever. The user does that. When user does that, a key pair is generated by the authenticator, regardless of if it is platform or roaming. A key pair is generated there. The private key is stored on the authenticator or and also synced to the cloud in case of like passkeys. We'll get there. But in general web authentication, the authenticator generates the keys and stores the private key. The public key then is you get the public key, and your implementation, with your implementation, you send that to your relaying party or your backend. So you only store the public key in your backend, right? So unlike other passwordless solutions, so passkeys completely depend on the WebAuthn JavaScript API, and it can only talk to the authenticators using the WebAuthn JavaScript API. So these are the entities and what processes it does. So once the authenticator creates a key pair, you can use your implementation to do whatever metadata stuff you want to do, send your usernames or whatever, and also the public key to your backend, and you store it on your backend. When it comes to passkeys, the flow is pretty much similar with slight exceptions. So we'll see, especially for sync passkeys. So let's look what the exceptions or the differences are. So this is the registration flow for synced passkeys, right? So when registration begins, the relaying party provides a unique random string. So it's a random generated string. It passes that to the client to start registration. And the user starts the registration flow, provides approval by touching on your key or by verifying your fingerprint or face, whatever. The user does that and tells the authenticator to start the key generation process. So the authenticator creates the private public key on the third step, and then it uses the key to sign the challenge. So the challenge that was sent by the relaying party, it uses this newly generated keys to sign the challenge. And then you have, now you have the signed challenge and the public key for you to send to your backend. So the public key and signed challenge is then passed to the relaying party by your own implementation, whatever you do in your front end. And the relaying party, like Auth0 or your own server or Google or whatever, they store that as user information. So you have, say for example, you will have your username, maybe your user email or username or whatever, then the public key, that's it. No other, you don't need any other information. Like you're not storing any sensitive information. It's just a public key. You can't do much with the public key, right? So that's the process for synchronized passkeys. The one thing you could notice that in the third step, unlike normal WebAuthn flow, in the third step there is a synchronization to the cloud part for sync passkey. So when the key is generated, it is stored locally, of course, in the authenticator, and a copy gets sent to your cloud. Say, for example, in the Apple ecosystem, a copy gets sent to the iCloud, and in Google, it sends to Google Cloud, or if you're using Bitwarden, they send to their own vault, but they send that copy over. So that is the only difference between hardware-bound passkeys and sync passkeys, that aspect. Everything else is the same for all kind of WebAuthn flows. And let's look at the login flow. Again, login flow is pretty much similar in terms of flow. If you don't look closely, you might even think it's the same, right? Again, the flow starts off with the same thing. The relaying party generates a random string called challenge and provides that to the client. The user authenticates the process by touching the authenticator or however they want to do it. Then on the third step, the authenticator selects the private key associated with that particular user ID and uses that private key to sign the challenge. Then now you have a signed challenge that you can send back to your relaying party. So now the relaying party uses that signed challenge and takes the public key of that particular user and just verifies that it is indeed a challenge from that particular user. So that is how public key cryptography works, right? So it does that, and if the challenge matches with the public key, you're authenticated. So pretty much, I would say pretty much similar flow in terms of how you do password authentication. You also do similar steps here and there. You have to do encoding, decoding, and all these things. Here you just rely on cryptography. And in most cases, you will rely on some library to do this. You're not going to implement this on your own. So that's the login flow. Again, on the third step, you can see a difference, which is only for sync passkey. In case of new devices, in case of a new device, it will retrieve the private key from the cloud and synchronize it to the local authenticator. That is an extra step for sync passkeys. Whereas in hardware-bound passkeys, you don't have that step because the authenticator will hold the private key. And this is how you can recover passkeys. We'll get into that. So this should be obvious by now, but still, let's see why we actually need passkeys to replace passwords instead of all the other options. Right? First of all, it is really, really secure. It is phishing resistant. So passkeys cannot be phished as they rely on public key cryptography, obviously. And these generated keys are bound to the domain that you created for. So you cannot have a fake website. Let's say someone sends you a fake website, right? If you accidentally enter your email and password, they get that and they can use it to breach your account. But in case of passkeys, if someone sends you a fake website, if you even accidentally enter your passkeys there, nothing is going to happen because it doesn't match for the domain because it's a different domain. So the passkey is not going to work there. So you cannot proceed further and they cannot get any data further. So that is how it is phishing resistant. It is remote attack resistant because you rely on physical keys, either tokens or your platform authenticator, so nobody can remotely breach your account. So you don't have to worry about someone getting your credentials and remotely breaching you. They have to be present on your devices, or at least they should have your YubiKey or something to do a breach. So it makes remote attacks much, much more harder. Yes?
You said passkeys are domain bound?
Yes.
Does that mean if a vendor changes their domain for the website?
You would have to, yes, you would have to recreate your passkeys.
Okay.
Yes. It is domain bound. That is how it is phishing resistant. They are not reusable, as in, since they are domain bound, for every service you would have to create a new passkey. You cannot just create one passkey and use it for all service. And it's a simple process, so you are not even going to notice that you are creating new passkeys for each service. They cannot be, they are not shareable since it's public private keys. You really cannot share them around, except for Apple. They somehow, they ended up implementing a shareable version where you can actually airdrop a passkey, which kind of beats the purpose, but yeah, they let you do that. So thank you, Apple. They are superior to password plus traditional MFA combination in terms of usability and in terms of security. And the most important thing, it doesn't rely on something you know. Instead, it relies on something you have, which is much more secure and much more harder to do social engineering or phishing attacks or remote breaches and stuff like that, because you'll be using biometrics and hardware tokens, right? And another reason is the human experience or the user experience, because passkeys have a far better user experience than regular passwords or password plus MFA combinations. I think if you try out the passkey process, you will see the difference, how convenient it is. It's flexible. It can be multi-device or single-device bound. You can use it with your biometrics or hardware authenticator. So depending on your preference, there are many ways to do it. Even in the same device, you have multiple ways to do it. It uses a uniform and familiar flow. At least within the same ecosystem, you'll have a uniform flow. So if you create a passkey on website A, it's going to be the same in website B, C, it's not going to differ. So you will know, okay, this is how I create passkeys, this is how I sign in. It's going to be the same, because mostly you're going to end up using your browser's UI. So if you're on Chrome, it's going to be the same. Of course, between browsers, it is going to differ, but at least on the same browser, you'll have similar uniform experience. And most importantly, you don't have to remember anything. For passkeys, you have to remember nothing, except maybe if you're using a hardware token with a physical, like a pin instead of biometrics or something, maybe you would have to remember the pin, but then again, you're only remembering pin for that particular device. You don't have to remember anything else, right? Everything else, even usernames, you don't even have to remember usernames. I'll come to that later. So passkeys are also very scalable. It is backed up and replicated in terms of sync passkeys in your cloud, like iCloud or Bitwarden or whatever. It is very convenient that way. It will end up in your new devices. If you lost your device, you can recover it, so it is convenient. They are discoverable by browser, as in your browser will discover that a certain website supports passkeys, and you have passkeys on the device or on your ecosystem registered for that website, and it will, for example, in Chrome, it will give you autocomplete for all passkeys for that domain. So with your username and everything, so you don't even have to remember usernames. You just say, "Hey, I have a passkey here." You select that, voila, you log in. As I mentioned, synced passkeys can be recovered and backed up and all those things. So that is how it replaces your password recovery flows and stuff like that. That is the equivalent of that, but it is not implemented by the backend. Unlike password recovery flows, which you have to implement, passkey recovery is implemented by the ecosystem, like iCloud or Google Cloud or whatever. Passkeys can also perform cross-device authentication regardless of ecosystem. For example, if you're on the Apple ecosystem, you can still use your Android phone to authenticate, and vice versa. So there is this cross-platform thing going on. And even if you're using a different device to log into, say, for example, if I'm using my phone to log into a website on my laptop, it is still secure because it ensures that my laptop is near my phone via Bluetooth. It looks for Bluetooth identifiers of the device and makes sure both devices are close by. If it cannot find a Bluetooth identifier, then it won't work. So it ensures that the other device you're using is physically present near your actual device. So again, to prevent remote attacks and stuff like that. So we'll see some demo of these. So as I mentioned, the passkeys are definitely way more secure than other options. So hardware-bound passkeys are the most secure option because they are equivalent of using FIDO MFA security keys. And of course, plain passwords are the least secure option, and you have variants in between. Sync passkeys are slightly less secure than hardware-bound. They are, I would say, sync passkeys are as secure as password plus FIDO-based MFA, like when you're using a platform authenticator, a second factor or something, it's as secure as that, because you're just cutting away the first aspect. You don't have passwords. You directly use your platform authenticator or something to verify. It's just synced across. And of course, you have social login, which is almost, I would say, as good in usability, depending on how exactly the flow. That's why I put it slightly less. But then again, the security aspect, of course, it's factual, but the usability aspect is kind of subjective, right? So different people might have a different opinion. One of my colleagues said that they would put hardware-bound passkeys as higher usability than passwords. So it's going to change. So if you don't agree with this usability ranking, which is on the vertical axis, you can scan this or go to menti.com, use this code, and rank based on your preference or how you think the usability is. And after the talk, we can see how the ranking came. We'll see if it matches with my subjective usability ranking or if you think otherwise. I'll give a second. No internet connection. Yay! Okay. Anyway, I tried. You can also do it later. I'll I don't know, tweet or something the results. Anybody managed to get in? Okay, 3 people, not bad. Okay, at least I get some data. Hey. Yeah. You also want to vote on security?
Yeah, because I think it's incorrect.
Okay. I would like to know. I'm always ready to correct myself.
And the sync passkey, why is it more secure than the password and the multi-factor authentication? Because if you have sync passkeys, you will probably have the password to get to the sync passkey.
Sorry, which one? Sync passkeys was?
If you have sync passkeys, how do you access these sync passkeys?
Uh, in your platform, right? So assuming you have already authenticated to your iCloud or something, right?
Yeah, but that's based on the password.
Yeah, but that is on the same level as the password plus FIDO MFA. It's not more secure than that. It's same. The vertical axis is usability. Security wise, it's on the same level. So it's not more secure. It's same as password plus FIDO MFA. That's why it is there. And this one is OTP MFA. OTP MFA is not as secure as FIDO MFA. If you get, because SIM card is easy to replicate or whatever. And emails can also be hacked more easily than a physical FIDO key. So
And can it be made quantum safe?
sorry.
Probably relates to current public key cryptography.
Yeah.
Does it accept the
It is as safe as current public key standard. So you can use different algorithms like RS or ES or whatever. You can use all available different algorithms, but that's about it. I think the maximum support is 512. So yeah, probably not. Probably not quantum safe.
Then I think that passwords is more symmetric key algorithms, and then that is more quantum safe than your FIDO solution.
Let's not go there now. Let's not go into the theoretical. We can discuss later. So let's see some passkeys in action. I need to. Oh, nothing there. Okay. So let's do some live coding. Hopefully it works. I'll show something there. I just need to. Okay, how do I? Yes. Oops. Is it for the back? Is it visible or should I make it bigger? It's okay? Awesome. So I'm going to create a Spring Boot application. So I'm going to use start.spring.io. Just two dependencies, Spring Web, Spring MVC, and the Okta Spring Boot Starter, because the Okta Spring Boot Starter kind of encompasses Spring security. It auto-configures Spring security and makes it OIDC ready. So it makes adding OIDC support way more easier. So I'm just going to generate a new app. It's done. Yes, I use VS Code because it's faster to load. So I have not much here. I need to close all these. Okay, I need these. Okay, I need to add a controller so that let's say home controller dot Java. Yeah, it's a very simple controller with a get mapping for the slash path. It's going to return your username. That's it. Nothing fancy here. I need to create an application properties file to hold my. I'm just going to wait. I'm going to copy it from another so that I have the keys. Yes. So I copied an application property. It's empty now. I'm going to create a new application. Of course, I'm going to use Auth0. I won't get paid otherwise. So, and yeah, I'm going to reveal secrets. You can get my secret and do whatever. It's a throwaway application. Okay, so I created a new resource server on Auth0 for OIDC. Let me copy my client ID. It's almost cheating, like doing this with, yes? Sorry? No, it can work from the root as well, yes. Spring Boot supports that. It's easier to put on the root, but because then you can git ignore it. You can also have the other application property in your thing with other stuff, but whatever you need to git ignore, you can put it on root and just git ignore it. It's easier that way for demos. So my And my domain, yeah, as I mentioned, it's almost cheating because doing it without zero is like not much coding. Just generate, I add few properties, and I demo. It's almost cheating, but I'll also show how to do it yourself after this, because I have to show this first. It's only fair. And yes, this my client secret. Please close your eyes. Don't look at my client secret. Yes, should be ready. Let's see. Startup. I need a YubiKey. Yes. So I have a YubiKey bio with a biometric thing instead of pin, so it's much more convenient. Because I'm on Linux, I don't. My platform authenticator doesn't work with WebAuthn. I mean, it doesn't work with pretty much anything. So, okay, let's see. Yes. I think it's not going to work. I think I missed something. I had the same issue once. Let's try. I think or I'm already logged in. So let's try in incognito. I think I'm already logged in somewhere. Yes. So the login box is from .0. All the client-side implementation is already there. The backend is already there. So we don't have to do anything. It's just an OIDC implementation technically. But I can sign up. Let me put in my bio. I can sign up with, let's say, test.com. Continue. So I'll be asked for a passkey. So I'm going to create a new passkey. So I touch my authenticator. It created a new passkey. And voila. So let's try logging in again. So I go back, continue again, and just touch, and this is the discoverability part. So the browser discovered that for this domain, these are the passkeys on this particular hardware, right? So depending on whatever hardware you put in, the browser can read and show you all the available passkeys for that particular domain, not for every domain. So if you're on google.com, it will show you only passkeys for Google and vice versa. So let's try this. Voila. So easy, right? So use Auth0, easy. So I have another demo that I'll show you as well. But let me switch to the other view. I need to find my nope, nope, nope. Yes. Where were we? Yes, here. So yeah, if you want to try this out yourself, you can go to that, you can scan or go to that URL, the repo. These are the steps. Of course, you'd have to create an Auth0 account, obviously, to do it. But you can try it yourself if you like. I'll give you a few seconds to scan that. There goes 1, there goes 2, there goes 3. I'm kidding. So, but yeah, I do have to move on. So, yeah. So I was asking, right? How if you think it is the same. So how does these are often confused? Like passkeys are often confused with FIDO MFA because they kind of use similar, devices. They kind of look similar. But how does it differ? I'm only talking about FIDO MF. I'm not talking about OTPs and all this. I'm only talking about using platform authenticators or roaming authenticators as your multi-factor. That's FIDO MFA. Technically, they were similar since both can be implemented using web authentication. And in case of hardware-bound passkeys, they are almost the same. The only difference for a hardware-bound passkey and a hardware MFA FIDO MFA is the discoverability part. That's the only difference. So there are some differences in usability. So passkeys, as I mentioned, are discoverable. FIDO MFA is not discoverable, at least not yet. FIDO MFA does not have a synced option. It's just hardware bound. Passkeys does have both options. And in case of sync passkeys, even more differences in usability and security. For example, for sync passkeys, you only need to do enrollment once. So if you enroll on one device, you get your private keys synced on all the devices, and you just start using it. You don't have to do enrollment in each. Whereas if you have multiple physical keys, you have to enroll in each key separately. Right, so that's a main difference. And the most important difference is passkeys are first factor authentication, and MFAs are always second factor. You always have to register an account with a username and password, and only then you can use FIDO MFA. You cannot use it as first factor. That's the key difference. There's still some challenges. It's not all hunky dory. Of course, it looks great on paper. It looks nice on demos, and probably even nice if you are on specific ecosystem, like on Apple ecosystem, or if you're only using Chrome. It's all great, but not everywhere. I think the main problem for passkeys is that it is still a W3C recommendation and not a standard yet. It is still a recommendation, which means it can change. It can evolve, it can change. So this is going to hamper adoption, right? So some people might think, okay, let's wait until it is a recommendation so that we can implement the final spec. And mostly there won't be a lot of changes between a recommendation and a standard, but theoretically there can be, right? Another key challenge is this is OS and browser dependent, especially keyword browser dependent. And you know what happens whenever there is a W3C spec and a browser, right? Yeah, we get inconsistencies. That's what happens. And we all know countless examples of that, right? Gladly, there is no Microsoft Internet Explorer to blame things on anymore. But still, even within Firefox, Chrome, all the so-called evergreen modern browsers, there are still a lot of inconsistencies when it comes to implementing specs, which sucks. So this means support may not be, and probably is not going to be uniform, and can become fragmented over time. And you can already see this in action. If you are using Chrome and Firefox, and if you try to use passkeys, you can clearly see the difference in terms of UX, usability, in terms of the convenience, syncing aspect, all that. You can see big differences, right? Another problem is it relies on big corporations like Apple, Microsoft, or Google to secure your private keys in their data centers, and do whatever they do with those. So technically, it does reduce the attack surface to few, but yeah, that's also not a great thing. So because theoretically, it can be breached, and those private keys can be breached. So there is that problem. And another problem, especially when it comes to enterprises, I saw this today with someone who was trying a passkey demo on our booth, is that you may not have access to have a nice passkey flow. For example, in your company, if Google Cloud or iCloud is blocked, you cannot do sync passkeys there. You could still do YubiKeys kind of thing, but you cannot do sync passkeys because it needs access to Google Cloud or iCloud, right? So those kind of issues will be there. And also, enterprises might want more control on things, whereas passkeys take that control away from the implementer to the ecosystem and to the platforms, right? That could be an issue for certain use cases. So yeah, we have still a lot more to go, but the adoption is getting bigger. Yes.
Yeah, what if you lose your hardware key?
If you lose your hardware key, you're yeah. So if you use hardware keys, always have a backup hardware key. That is like for not just for passkeys, even for MFA. If you're using hardware key, you should always have a second hardware key as a backup or another backup, because hardware keys, if it is lost, you cannot recover. Sync passkeys, yes, you can recover, but hardware that is why they are secure, because.
What can someone else do with your hardware key if they find it?
So for passkeys, for FIDO-MFA, you don't need to have a PIN or biometric on a token. You just need to touch your token. But for passkeys, if you're using, let's say, this one, YubiKey Bio, it has a fingerprint sensor. Then you have to touch that only. So if someone gets this, they should also have my fingerprint. And if you have the normal YubiKeys without the fingerprint, where the metal touch thingy, you need a PIN. It will prompt you to create a PIN. So you will still need a PIN. So if someone gets your key, it's not much they can do unless they have your fingerprint or a PIN. But yeah, so. Compatibility, right? Yeah, if we are talking about anything web W3C, we have to talk about compatibility. So Chrome has the best support when it comes to passkeys, especially for platform authenticators, like your TPMs, Touch ID, Face ID, whatever. It has support on almost everything except Linux. Boo. Safari on the Apple ecosystem, it has good support. Firefox, yeah, I mean, not great. Doesn't work well with platform authenticators on all ecosystems. Brave and Edge, since it's Firefox based, has better support, but not on Android. I wonder why. And when it comes to roaming authenticators, the support is much better. So Chrome supports roaming authenticators for passkeys on all platforms. Works great on Linux as well. Safari, again, on the Mac ecosystem, the Apple ecosystem. Firefox, better, not on Android, but everything else. And the others are also almost there. So platform authenticators, roaming authenticators have much better support for passkeys at this point, because we have it for some time as in the form of FIDO-MFA, because it is pretty much the same. So we have better support. Whereas platform authenticators are kind of new, and it is going to take time for all platforms to have uniform support. How long do I have? Huh? Out of time? Really? Damn. I still have one more demo. 1 minute left? I started 2 minutes late, so I'm going to go quickly. So web for Java, right? So for Java, we have 2 libraries. We have a Java WebAuthn server from Ubico. It's not 100% FIDO2 compliant, but it supports most of the attestation formats. You can use it as a relaying party implementation. It supports passkeys. And it's from Ubico. And we have WebAuthn for J, which is 100% FIDO2 compliant, supports all attestation formats. You can use it for passkeys and as a relaying party. It is used by Keycloak and Spring Security, and it's also Kotlin friendly. So I built a relaying party server using the WebAuthn for J's Spring security library. I cannot live code it because I don't have the time. No, I cannot live code it anyway because it's a bit more involved. But you can go to the repo, clone it, and try it yourself. Can I quickly run this? Do I have the time for that or no?
Real fast.
Okay, real fast. Yes, real fast. Okay, I'm going to. Okay, CD. Yes. I wanted to walk through the code. I thought I had 50 minutes, no? 45 minutes, no? Damn. Yep. Where is my? Where's my? It's gonna. Am I there? Yeah. So this is pretty bare bone application. I have a few beans configured for WebAuthn J. I have a controller which handles login and sign up. But yeah, I wanted to walk through the code, but I don't have time. So go to the repo, look at the code, try for yourself. This is how you will implement a relaying party for WebAuthn without any stuff. But I can register, use the key. It will ask me for approval, and I can sign in with that. So again, discoverability part, I can select whatever is there. Yay! Am I done? No, I'm going to quickly. What is the? I'm sorry. I'm really sorry. So some resources, very useful if you are interested. WebAuthn for me, webauthn.me, built by Auth0. It has a really nice visual debugging for things. You can see visually how everything works. You can try it out and everything. We have a challenge at our booth. If you want to try passkey challenges and win some cool gifts, try this or come to our booth. I promise no more things. Thank you.